Okay, so welcome to the first afternoon session of PADL. And so we have 3 talks, and the first talk is going to be titled Marketplace Logistic via Answer Set Programming, and the talk is going to be given by Mario Alviano. And in fact, I think I would say this is the University of Calabria session. All 3 talks have people from Calabria. So first 2 talks are going to be by Mario. So Mario, the floor is yours.
So many thanks. Yeah, it's the Calabrian session. So, I work about marketplaces, okay? So what is a marketplace? It's essentially a website where sellers sell products, but there is not only one seller, there are several sellers, several products, and it gives several advantages to the small businesses because they can enlarge the amount of customers they have, because obviously they can sell on the internet, and they don't need to master a website. They don't need to handle the website. On the other side, for the owner of the platform, it's a much more complex website with respect to an electronic shop, because there are 2 different kinds of transactions that must be handled: business to customer and business to business. So, who are the main actors of this kind of marketplaces? On the one side, there are warehouses that they want to sell products. On the other side, there are final customers. They would like to buy products. In the middle, there is the platform, the marketplace platform. First of all, the platform must collect products proposal, selling proposal from the warehouses. Then it must accept orders from the customers. And at some point, it must decide how to deal with the order of the customer. So who are the warehouses to contact for fulfilling the order? And the big problem is that there are several ways to fulfill a given order. So if we consider this example, so we have several products in the basket, and they can be given by different warehouses. So, for example, one can involve all the warehouses, but this it's very likely a too complicated solution from the point of view of the marketplace. So it must interact with everything. So one can try to restrict. Let's just consider these 2 warehouses. That's good. So it's a minimum amount of warehouses to contact, but on the other hand, there is at least one line that should be these 5 elements that you must necessarily split between the 2 warehouses. And this is maybe not optimal from the point of view of how many interactions you have to do with the warehouses. Then it's also possible to use these 2 warehouses, and then in this case, also this is also optimal from the point of view of the warehouse logistics because you don't split any line. Very important, if there is any difference from the customer in terms of how much the customer is going to spend on this order, this should be taken into account. Now, the problem can be given in different ways. We had a specific setting that was from the marketplace owner. And in this setting, we were having products, same product, same price, regardless of the warehouse. This price was agreed with the platform. The warehouses synchronize the availability of products with the platform, and then the buyer simply compose the order. They don't care about the warehouses because all warehouses provide the same price, so they don't really care who is sending the items. But on the other hand, the warehouses possibly charge some amount if we don't give enough money for the same order. So there are shipping fees that can be waived out, and this can be of interest for the final customer. So what the marketplace has to do? First of all, while the basket is updated, adding products, removing products, we want to give a feedback to the customer and say, you are expected to pay this amount plus this expensive for the shipment. Before asking for the payment, the customer would like to have a confirmation. I'm going to pay this amount and I'm going to receive this number of shipment. So maybe this is less frequent and you can spend a bit more time on this calculation. Finally, once the order is fulfilled, is paid, it's time for the final decision. So we have to decide also which warehouses to contact and what to ask to each warehouse. So again, the first of these three tasks, we must be super fast because we have to do this very quickly. Okay, so and it's a frequent operation. The second one is a bit less frequent, we can spend a bit more time. The last one, technically, it's an offline operation, so we can take even more. Now, I was contacted by this marketplace platform, and I was asked, can you help us, okay? Because we have only on Logistic, and apparently it doesn't work very well. We know that you are an AI researcher, and in their mind was obviously deep learning. But then I replied, that's deep reasoning in case. It's combinatorial search and optimization. So we are going to use maybe answer set programming for this. So how to approach with answer set programming? You need a formalization of the problem. So maybe warehouses, we can index them by integer. Products, we can index by integer. Then at this point, every product has a price. Every product has an amount of products in the order. Every warehouse has a shipping fee. Possibly this shipping fee can be waived out. And then for every product and warehouse, we would like to know how many products are available in that warehouse. What's the task is to compute this other function. For every product and warehouse, how many products are you taking in order to reach these numbers? And then there are objective functions. First of all, we would like to minimize the shipping cost. After that, we would like to simplify the logistic, so contact warehouses only if they are needed. And finally, we would like also to simplify the logistic, the interaction with each warehouse by minimizing the number of pairs, warehouse products that are involved. So let's consider a simpler example. So here we have 3 warehouses and 2 products. There are 4 units of product 2 in warehouse 1. The warehouse 1 would like to give us free shipping if we spend at least 8, and otherwise it's going to charge 1. Then there is the price of each product. For example, product 1 is going to cost 4, and the order includes 8 units of product 2. Now, how we approach this problem? We use the ASP Chef. So ASP Chef is a nice tool for fast prototyping. And essentially, we started with a numeric format that the idea is this is going to be used by the platform to exchange data. What you do with this numeric format, you would like to apply a sequence of steps that in ASP Chef, we call a recipe. And you end up with a relational format that is what we usually use in ASP. And this stuff you can easily share with a link that I should have here. And you see, as a side effect, you also have this nice visualization, a table. You start from this input. Here there is a recipe, and here is the output. But where is the recipe? The recipe is actually hidden. So we can show here. There are several ingredients, and if we want, we can also enable the editing. And you see that here there is the real content of the recipe. A recipe is something that you run from the top to the bottom, start with model, apply something, get model, and so on and so on. Okay? So you do several manipulations of this kind. Now, okay, that's just the input. What about the real solution? So how you get this solution? Yeah, first of all, with this initial step, you already give to the how to say, to the customer, to who wants to have the product, you give a nice visualization to say if we correctly understood the problem, and you just send a link. Because you see the recipe is fully encoded here. There is nothing running on the server. Now, there are several ingredients you can add to the recipe. So here it's an optimization problem. So very likely you would like to try different options to see what option of Klingo, actually Klingo WASM, perform better. And we have an ingredient for this. So that's a bit more, to say, easy to use with respect to reading the documentation. You have a form, and you select what you want. Then you can add other elements. For example, if you need the at term that in ASP are interpreted function symbol, you can define with Lua, with the Lua scripting, no Python at the moment. And then you can use the function you defined in a previous ingredient in a program that maybe is going to compute an optimization problem. But without further ado, okay, let's expand the previous example, and I will try to do live. Okay, so I will put this stuff down. Let me move this on this side, and here it's the content of this recipe that I use to share tutorials also, okay? So the first thing I want to do is to show the header bars, and I already have done. But actually there is also another way to do this. Let's see if I can activate this. So you press escape to release the focus, and then you press B. Okay, you see this easily switch the header bars. Then maybe you want to enable editing, press E. Maybe you would like to hide temporarily the right panel, just press the right arrow. And then we would like to show the left panel that contains the actual operation. Now, we would like to add a set optimization strategy. So I can search from here, and I can use F to jump to the filter. Then I will search for opti. And you see that here there are a few key bindings that will speed up the development. So if I press 1, and I go down, down, down to the recipe, you see that I have a new ingredient in there, where I can explore different optimization strategy of Klingon. Now, if I want to add the at term, I'm going to search for terms, for example, press 1, and I have the new ingredient in there. Now, I would like to set as the encode predicate underscore underscore Lua underscore underscore. The content is going to be a function that gives me the minimum between two values. What is the result of this stuff? It's essentially this Lua stuff in there. Would I destroyed something? Okay, that's the live demo. It's always problematic. Okay, some strange timeout. Okay, so what you do with this strange predicate? It's a base 64 encoding of this content that we are going to use in another ingredient, for example, the optimize. Now, how the optimize is going to work? You see, first of all, there is a decode option. The decode option, you specify a predicate that contains base 64 encoded content that you would like to be part of this program. So now I can use the at term in this program. What is the program? By the way, you see that the Lua predicate disappeared from the output. So let's keep it because we will need later. So we activate this HO option. So let me copy this content in there. And you see that now we have something down here that is the solution that we will want. So let me go back to this, to the slides. And let me see if I can remove this stuff. What about the encoding? Okay, I just copied and pasted, but it's really easy. Okay, so we are just guessing the select function. We are checking that we fulfill the order, and we have a weak constraints that define the first optimization function. If there is free shipping, we want to use it. Otherwise, we have to pay for the shipment. And I put the weak constraint at the level 3. Why? Because I would like to use the same encoding also for addressing the other two problems, because they are very similar. So in ASP, you approach multi-level optimization with this at something. Now, we have seen that in the output, now we have this, select this, select this, select this other, but that's, again, it's a relational format that it's good for ASP, but it's bad for me. I don't want to read this stuff. So what I want is to jump from this table to this other table. How can I do this? Okay, so I would like to highlight the involved warehouses. I would like to highlight maybe in green the, can I? No, I can't. In green, the free shipment, and I would like maybe to highlight in orange the involved pairs, so that I will understand immediately the solution, and I can show also to the customer. So again, this stuff, you can encode, quite easily here. So I'm gonna, okay, so I don't want to look the right panel, so let me remove the right panel. I need the headers. I will add the search models. Hey, come on, guys. So if I go down, 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 you see that I have a search model. It's similar to optimize, but this time you just compute a model, not an optimal model. After that, I would like to show a graph. The graph, I'm going to encode in a specific predicate that, since I'm lazy, it's going to be just G. What I will do, where this predicate G comes from, yeah, maybe it's going to be similar. It's going to be similar to this other ingredient. So let me copy the content. Hey, come on. The content from here. I will paste in there, I hope. And you see that at the moment, I have the same table, but now I'm going to modifying a bit the encoding to do what I want. So the first rule is going to draw these parts of the table. I would like to replace with the one that possibly highlight in yellow. And you see that it's updated instantly. Then maybe we would like to color in red the involved warehouses. So let me go down and let's add this rule. And then I would like to color in green the free shipment, and there it is. Now, second objective function. We want to also, if there is a tie, we would like to minimize the warehouses involved. Now, simple approach, we can take this new week that essentially minimizes the number of involved warehouses, and we can place somewhere in the recipe, where? Here. Okay, so we can modify this, and you see that the table is updated. Okay? That's one way. But there is an alternative way, that is that you stack one problem after another in the same recipe, so that you will have a better understanding of the problem and you can discuss with the committer of the job. So how can I do this? So first of all, we have to delete the previous solution. So you can do this by hiding predicates, or you can filter them with the low-code approach. So select predicates does exactly this. So I'm going to keep everything, with the exception of the select, that it's the output that we want to produce at some point. So what is the result of this stuff? Essentially, select disappeared from this output. After that, let's hide the details for a moment. ST. And yeah, let me zoom because I don't read. We would like to do a copy of the ingredient number 9 that contains the optimization function. So how can you do a copy of an ingredient? Super easy. So if you press H, you activate this inline help, and then there is this duplicate operation. Then move this at the end, and this is the ingredient we are going to modify later. But before, let's copy also search model, graph, and I think we can stop at this point. So we have new ingredients. We would like to add the new weak constraint to some of them, actually to the number 13. So let me show the detail. Escape D. Let's go down, down, down in the recipe. And this one, I would like to add the new weak. And now you see that here we have the intermediate solution, and here we have a better one. So we go from one to the other in this way. Now the third one is going to be similar. Okay, so it's just adding another constraint that minimizes the number of pairs. Now you can do the same copy and paste approach. Technically there is another way. So I think we don't have the time to see, but you can essentially add an interceptor in the middle of the recipe. If you add a new ingredient, it's going to be intercepted at that point. Among the ingredients you can add, there is the recipe ingredient. So you can put a recipe inside another recipe, and you can use a recipe to implode a portion of another recipe. So some of the ingredient will become part of this recipe ingredient. Then what you do with this imploded recipe, if you want, you can explode. Now, if you explode 2 times, it's going to copy for the last 4 ingredients in this way. And then you modify what you want, you get the new table, and you have all of them in the same place. You can, as we have seen before, you can disable details, editing, headers, and so on. You get a nice visualization for someone that is interested only in the output. You can share recipe with the URL. If you want, you can shorten the URL. Okay, so you attach your GitHub account with a token, and you can save the recipe on your own GitHub with a short name, and you get also versioning of the recipe. I don't know, do we have this? Yeah, for example. Okay, don't mind. Now, what we have done at some point, said, okay, let's have a real implementation now, okay? Because this runs on the browser as an overhead and so on. Now we want something running fast. We consolidated the implementation with the Klingo Python API. We compared with the greedy algorithm that was essentially at every iteration selecting the warehouse that was providing more products. It's a reasonable heuristic. Then we said, okay, let's generate instances that can be challenging because those that we were having were too easy. And this is the result, okay? So execution time. The greedy algorithm is always immediate, zero time. ASP, the blue one, only apply the first weak constraint. The orange one applies the first and the second, and the light orange, I don't know, red and orange, the last one, select all the weak. You see that the performance is acceptable, unsat instances are here on the right. So the time is fine, okay? It's also compatible with the requirements we were having. What about the shipping cost? Now there is a big difference. So the greedy algorithm, it's often unable to understand that there is the opportunity for minimizing the expenses. ASP always find the optimum, and often this optimum was 0 in these instances. Now, if we activate the second week, you see that we also improve the number of the number of warehouses that are involved. The greedy algorithm is already good on this, but you see ASP can actually give the optimum. And if you activate the third week, you also improve the number of involved pairs. Now, we tried also to take the formalization and do a mini-zinc model. I think it's just a matter of taste, which one is more readable, better, and so on. Now, on the execution time, we used OR tools for mini-zinc, and this is the result for that model. So it's somehow slower. Now, what if you want to add the second objective function? Now, to the best of my knowledge, the only way is that you compute the optimum cost from this model, from the previous model, then you fix the cost and you ask for the second objective function. This is how multi-level optimization is done in Minizing, from what I know, and I think now it's not a matter of test anymore which one is more readable. Okay, so because here you also need some scripting to link these two. Execution time we haven't tested because anyhow it's going to add something to this gray bar plot. If you add the third optimization function, you go with the previous two steps, then you need another portion for minimizing this other. And again, the approach of ASP is more uniform. Now, not that with this I want to say that we are better, okay? Not because of this at least. But we were having 3 related problems in the context of marketplace logistic. We obtained a uniform solution in ASP and we are happy, okay? And last but not least, the most important message of this talk is I want you to try ASP Chef. Thank you.
It's a bit too quick for me to read, but when you do this with Minizing, you only fix the bound, right? You don't keep parts of the...
Yeah, you only fix the optimum cost, because there are several ways to obtain the optimum cost, possibly involving more warehouses than required, and then you would like to reduce the number of warehouses. Okay, so you can't fix the full solution here. You only fix the cost here, okay, with this constant. Okay, so in shipment cost, in the data file of Minizing, you have to provide the shipping cost.
Okay, interesting. And do you give this as a lower, upper, or exact?
Yeah, exactly. Yeah, we went with equal. Okay. Yeah, maybe if you say no more, no, it will be maybe just more challenging. What do you think?
I have no idea. I only tried this with Klingo, and there it was kind of interesting to see, even if I know the optimum and put it in, right? From the
it's really bad.
It almost doesn't help compared to just optimizing.
Yeah, exactly. It depends on the algorithm. It can be even worse because this kind of constraints involves all the products. So this means it's a very huge weight constraint, and the number of clauses that the solver is going to learn from this huge constraint will be a killer. Okay, and this is why when you approach optimization problem, often the unsat core analysis provides better performance because split the objective function only to where it really interacts. Okay, that it's different from, for example, linear search sat-unsat, where you start with a solution and try to improve this solution. Okay, so in this case, it means that after the first solution, you start introducing a weight constraint that asks for a better solution, but this weight constraint involves all the literals in the objective function, and again, the solver is going to have trouble. He's going to learn very long clauses. Okay, so I think this approach to multi-level optimization semantically is super fine. In practice, it's going to suffer.
Anyone has? Okay, well, let's thank the speaker and move to the...
Thank you.